Hi, I'm George Hammond, Senior Conference Producer for Technology Networks, and I'm here to introduce our next talk, Advancing EV Battery Potential, Data and Analytics Solution. I'm incredibly pleased to welcome Jill Pestana. Jill is the founder and CEO of Pestana Solutions, a consulting firm that helps high-tech companies, especially in the battery industry, communicate their innovative technologies to wider audiences. With over a decade of experience as a battery scientist and engineer and 15 patents, Jill has consulted for startups and Fortune 500 companies. She also educates over 250,000 people on her YouTube channel across the nanoverse and is dedicated to building a sustainable battery value chain and clean energy future. A very warm welcome to you, Jill. Following the presentation, we will also have a Q&A session, and we welcome any questions that you may have. Please ask questions using the Q&A system to the right-hand side of the video player. And without further ado, I would now like to hand over to Jill to begin her presentation.
Thank you so much for the introduction. I am so excited to talk to everyone today about data analytics solutions. So you heard I founded Pestana Solutions, and here I'm representing one of my clients, Mecantis. I will talk a bit about why I decided to work with them and what they're providing. And also, I'm excited to get into a bit more about when it comes to EV batteries and the industry. What are we seeing as far as the trends in the value chain? What are the challenges that they're facing when it comes to battery R&D and quality testing for cells and packs? And then the Mecantis platform solution, which addresses these challenges. And I have in particular two case studies, and I hope they apply to you wherever you are in the battery value chain. The first one is cell HPPC testing, and the second is battery quality assurance. And then I'll talk a bit about the future. What does the future hold for battery data analytics? Followed, of course, by the conclusion and questions and answers. But overall, I want you to take away these main things. The first is that these companies that are conducting these electrochemical testing of battery cells and packs are facing significant challenges in managing, analyzing, and using battery data across their operations. So if you're in academia right now, I think some of you are tuning in from different universities, maybe you're a student, just know that if you are doing some kind of electrochemical testing of battery cells and packs, this is something that this skill is very important right now, and a lot of companies need help with this. The second takeaway I want you to have is that Mecantis offers solutions tailored to helping battery and product companies with making the most of their data. And this is something that resonates with a lot of people I talk to who are working in the industry, which is how can you extract the most value from all the data that you're gathering from your cells? I mean, even just one cell, you're gathering so much data just from one test. Imagine, millions of cells. When you get to that order of magnitude, you need to find better systems, and Mecantis offers that to collect, manage, and analyze that data. When we think about the EV battery value chain, right, we have from the raw material side, the mining and extraction, through materials process and refining to component manufacturing. We're talking anode, cathode, separator, electrolyte, to cell production, then battery assembly, the battery in the vehicle integration, and then in use. And finally, with the battery recycling. And this is a circular process, we're hoping, as far as all the regulations are going right now, is pushing for that circular economy where we then take the recycled battery material and feed that into raw materials, right? And in my career, I started out as a battery scientist and engineer developing silicon dominant anodes. And as a scientist, I was performing that electrochemical testing on cells and component evaluations and even doing I would say the majority of my job was actually doing materials characterization and analysis. So operating all those SEMs and TEMs and XRDs, right? And even in this one role where I was focused, at a small battery startup company, about 60 people, Innovate, if you've heard of it, right? We were just R&D phase, pilot scale production of pouch cells. This was one part of this full battery value chain, and we were processing so much battery data off our cell testers, off our potentiostats, all the equipment, and then all the analytical side of the materials characterization part that I was doing in a nearby lab. So even in this world, there was so much data that we were navigating and having to deal with. And I'll talk more about the challenges with that. But I want to paint the picture that, you know, as I grew in my career, I went into consulting. And in my intro, they were talking about how I led the North American battery consulting team at Accenture for a bit. There, I was consulting with Fortune 500s, utilities, OEMs, and all of that on their battery development and deployment. And when you're talking about these global corporations with battery data, you can imagine you have multiple teams focused on multiple parts of this value chain because a lot of companies are vertically integrating. And so it becomes they need to have the data visibility and awareness across the full battery value chain. And I'll talk about like one example of this. This is just a made up example, but this is, I think, something that could be very well true, which imagine there's a automotive OEM, right, developing a battery pack. And they're owning the cell manufacturing process through the recycling process. And let's say they're wondering on the cell manufacturing process, like, oh, should we choose between this type of graphite or this other type of graphite, for instance, for the cell, or this type of cathode versus this type of cathode? And they're looking at the cost. The cost is such a huge factor in decision making when it comes to cell manufacturing. And the material cost, especially the cathode cost, is such a big part of that. So evaluating, which cathode should we pick? They may at first glance go, oh, we want the cheaper cathode. We want to use the cathode that's going to cause the largest return on investment from our cell manufacturing. But let's say down the line in the vehicle, one cathode material versus another, the more expensive cathode material actually adds more value to the vehicle or makes it in a way where later on down the value chain, downstream, using a more expensive material actually saves them money. A lot of companies don't have this visibility right now across their operations, and it's a huge challenge, right? They're only thinking in their own sliver of their operations and of their value chain, and different departments are very siloed. And so it's a huge challenge to bridge these silos, making sure everyone has the right information at the right time to make quick decisions. So you can imagine that's, just one example. There could be millions of different examples of this. And I just want to focus on for Mecantis. There's so many data solutions for different parts of the value chain. This platform is for battery data from around the materials to component side through battery pack assembly. So we're talking cell data from testers and cyclers to pack data from testers and cyclers as well. So not in operation vehicles and not necessarily on the mining traceability side per se, but you can do traceability of cells, which I'll talk about. And this gets us into, when we're thinking about not just going back for a second, not just about this part of the value chain, but there's different stages of development when it comes to batteries. Within the EV battery development cycle, you start with R&D. You're doing your research in the lab, developing a battery pack. This is like the work I was doing, or developing a cell or a pack. This is the work I was doing at Innovate Corporation, developing silicon dominant anodes, right? You're starting with just R&D cells, figuring out what is the vehicle and cell and pack requirements, and how do I make sure I'm designing cells to meet those requirements? And then you're testing, you're fabricating, testing, and developing and validating the cell and packs to make sure they meet those requirements. And at this stage, it's really important to make sure you're setting up the supply chain to source cells and set up the plant to manufacture the cells and packs. Then once you figure out, okay, we figured out this cell performs well, we're ready to move on to mass producing it. That's the production phase. And in this production phase, there's still a lot, maybe even more so, cell testing, but it's more quality assurance testing. You're taking batches of cells that you're getting off a production line and trying to figure out which ones are your top performers, mid-tier or lower tier performers. You're also doing the pack assembly, and you have to make sure you're matching cells that are very similar in their properties with each other for best pack performance. So it's less of an R&D, more of the production. And then you have in-service vehicles. So then the battery goes into the vehicle for battery operation. You have the battery management system and telemetry data, monitoring the battery's state of health, or another metric is state of power. That's a very interesting one. And then finally, there's the data and information at recycling, end of life, or repurposing of the battery. And so when you're thinking about using a platform to gather all this data and manage and analyze it, Mecantis focuses on for R&D as well as for production phase. So not so much in vehicle operation or end of life. And in my work, I've experienced so many companies' challenges when it comes to pack R&D and cell R&D and production. So with the cell supply, companies right now are struggling with securing a supply chain. With the new administration that came in the United States, I'm based in California, so that's front of mind for me. They're currently figuring out how can they provide the right kinds of incentives to make sure companies can secure the critical minerals needed for batteries. So it's a very current issue right now, and standards committees are currently advising on this. There's also challenges when it comes to the complexity of the joint ventures or JVs and vertical integration. So I talked a bit about that, about OEMs are more and more trying to own the full value chain of batteries from the raw materials through to the recycling. But to move quickly for that, especially in the US, companies want to move quickly, and Europe too. They're approaching it more as like instead of building out their whole operations, to partner with other companies who could do that, like automotive OEMs partnering with Asian cell manufacturers. Tesla may be a slight exception to this because they're really trying to vertically integrate. They did have the joint venture with Panasonic, but they're gearing more towards producing cells themselves or even partnering with cell manufacturers in China. And then there's also the geopolitical instabilities that affect the supply chain that add some volatility and some challenges. Then for cell and pack IP, this is another challenge because it's like, okay, when you're forming a joint venture, who owns the IP? When you're developing the cell and pack technology, how are you going to make sure that you're protecting your intellectual property? And data is a huge role of that because you need to have the data to show what is the differentiator of this technology versus others that have been patented and really demonstrate that to secure the IP. So a lot of companies are choosing to do trade secrets instead. That's another topic. But it's unknown also when a company like an OEM is working with a cell manufacturer. Sometimes they don't even know like what the details of that cell design are that they're getting from that cell manufacturer. So there's a lot of unknowns when it comes to what is the intellectual property around a cell or a pack. And so it's hard to track that data. Then you have cell and pack modeling. I actually just got off a call this morning with companies that are looking into how do we model a cell in a pack to track, the state of charge or detect thermal runaway. But even more upstream in R&D, a lot of companies are trying to understand how do we model battery aging? How do we predict this so we can forecast how the vehicle will perform, for instance? And oftentimes there's not enough data to form like AI or machine learning models. And even knowing what data is most important is really confusing. And finally, for cell quality assurance or quality assessments, companies have trouble when they're global and say there's a headquarters in one company or one country, and then they have the quality checking and cell production or pack assembly in a different country. It's really tough to get real-time visibility across those operations. And it can be really hard to transport the cells in different places. So it's good to have the data capabilities on both sites. And you're dealing with millions of cells a month. So that could be a large data sets. And across all these challenges, different themes emerge. You have traceability. You need to trace the material through and cells through from raw materials through to recycling. This is mandated by policy like the EU battery directive. Then you have maximizing data value. So I talked about how things can be siloed. You could see there's a variety of battery data. How do you know what's important and how do you know what to focus on? And how do you gain access to seeing it quickly so that you can take the value from that in different ways. And then bridging silos is, of course, super important to make sure that these companies are successful and making sure that they understand across departments or across different operations what the current status of their operations are. So, how are companies currently managing their data? I've had conversations with tons of companies, and my experience myself is with actually Excel and pivot tables and using Minitab for statistical analysis for R&D. A lot of companies are using non-specific platforms and tools for battery data analysis. And this causes some challenges, like it's a slower time to make data-driven decisions because you have to adapt the tool to work for you. You have to create your own graphs or your own plots. And then when teams develop tools in-house, like Pythons, I've heard of issues where with even in one location, a team will have several versions of a similar Python script to analyze a certain data set. And there may be discrepancies, and that can cause issues when it comes to trying to understand what the data is talking about, because different people will come up with different results. So it's a huge challenge there. And then if you're going for a platform that's more specific for battery management and analytics, a lot of them offered on the market right now have a high cost and onboarding fees and lock you into an annual or multi-year contracts. So they're not as quick and agile as some companies need as they're scaling. So starting from like pilot scale, scaling to giga scale, you want something that can grow with you and accommodate what price point you're at. Also, some of them are more inflexible when it comes to data views. You don't get the right dashboards and graphs that you'd like to see. They're not very customizable. And so if you're working with like different chemistries or have an interesting, innovative production process, for instance, it's harder to view that. And there's not many features in a lot of these platforms for batteries about doing more precise, not precise, but specialized testing like electrochemical impedance spectroscopy, HPPC, which I'll talk about a little bit, DRT. So they lack these integrated features to do this analysis quickly, and they won't integrate with your current systems or advanced analytical tools. If you want to use AI or machine learning, it's harder to input the data into that model. And that's when a Mecantis comes up. So Mecantis is that solution where you can efficiently manage and analyze large volume of battery cycle tester data. And it performs a lot of automated processes, and it has the specialized features just for battery companies. It actually has a really interesting origin story. So there was a company, a cell manufacturer in the US, who was using an established data analytics platform for batteries, but it wasn't doing what they needed it to do, and it was too expensive for them. And so they actually called up the CEO of the company, called up the founder of Mecantis and asked, "Hey, can you build this for me?" Because he is an IT professional, he's built software before. And so the CEO, Howard, and the CTO, Jonathan, who knew each other, partnered together to create Mecantis per this cell manufacturer's needs. And then what happened was they built it for one company, and people left that company to go work at other companies. And they were like, oh, well, at this new company, like, we need Mecantis here because it's so much better than what the Excel sheets or Python or the other tools that were on the market. And so the platform's really grown organically to fit a bunch of customers, not just in the cell manufacturing, but even the number one product company in its category uses Mecantis and throughputs over 30 million cells a month. So this is not just your startup tool. This is also for high volume global production. And the way that this works, so when you have a bunch of cycle testers and everything, right, like Arbans, Maycors, they have a certain protocol to uh, manage and analyze, or some of them have analytical features, but mostly just manage that data. And Mecantis can be directly connected to that through APIs to automatically upload that data into the platform. So you don't have to lift a finger to do that. It's automatically uploaded, spreadsheets, data loggers, you name it. And then you have the centralized battery data platform. It's like a web app that you just access on your computer, Mac or PCs, and you can view the data, you can graph it, create reports, create workflows. It has analytics solutions that I'll talk about, and even some modeling techniques like DFT, electrochemical modeling. And in addition to that, you don't just have the data in the platform, it's very flexible. And so you can actually integrate it with your APIs into, say, you want to take it on to Python or into a CSV file or wherever you want to take it. You can do that as well. So it doesn't lock you into the platform. It just adds more flexibility and accessibility to your data. So I want to talk about enough about the platform. I want to talk about how it's been used. Like, what are customers using this for today, and what meaningful results have they received? So this is the state of the art when it comes to battery data analytics, and I'm really excited to share about this use case for hybrid pulse power characterization. For those of you who don't have much experience with HPPC testing, I'm happy to give a short introduction to it, but I encourage you to, look it up to learn more. It's a really cool technique and there's a lot of value in it. So imagine you're driving a car and you're pressing your foot on the pedal over and over, and you want to make sure that your vehicle is going to be operational into the future and you're not going to degrade your battery. Well, HPPC testing basically simulates that foot on the pedal acceleration by applying pulses of current to your cells. And so with that pulse, though, comes so much juicy information about batteries. You get the battery's dynamic performance characteristics, like you can understand states of, so you can also perform this HPPC at different states of charge over time. And I'll show a graph of what this looks like. That really paints a better picture. But you could test this under a variety of different conditions, like states of charge, temperature, environmental stressors, different current loads. And while this provides so much data, it's kind of an incomplete picture. So you want to get more data on other techniques in order to model the rest of your battery performance. So this is just one piece of a array of different data you want to collect. And so when you run this test, there's the typical way of doing it, which can take weeks because the test itself only takes about 12 to 24 hours. But the analysis side can take a long time depending on how granular you want to get. So picture this, you have Mecantis, you're performing an HPPC test. So you have the cell metadata, which is the information about the cells, that you have a label for each number of the cell you're testing, the cycles that's been cycled, its open circuit voltage, OCV, the first cycle efficiency, different characteristics. So it's all the data about the cells that you want to have. It's customizable. Then you create a test plan in the platform, sharing how are you going to perform this HPPC test. And this can be a standard test that you develop. And so it's a pretty quick transition to just inputting it into the platform. And then you can check the real-time status of the testing while it's happening. So because it's connected with the equipment, you could tell. But for an HPPC test, it really doesn't last that long. Like I said, it's just about like 24 hours or so at most to perform the test in most cases. Then once you've performed the test, you just go back to the platform. You go to this dashboard where it says analysis, and you can see there's a bunch of different types of analysis listed here. This is not comprehensive, by the way. This is a demo version, so there are more. But you could see there's like you can compare different cells and the grouped data. There's a circuit that's equivalent circuit modeling for EIS. That would be a demonstration if you want to see that. I'd be happy to share. And we're focusing on HPPC, but you can see there's DCIR, formation, normalizing plots, storage testing, and more. So then you have the data, you click the start button to start, and this is, it goes into another dashboard view from that, where you, on the left here, you have a variety of different ways to see your data. So the view we're looking at here is just the raw data, the data of the test. In the blue, you have the voltage versus the time, and you could see the voltage dips down each pulse, and on the orange here is that current pulses from the HPPC testing. So I mentioned it was like a foot on the pedal. So each time that current is pulsed to a different level, you can see the currents on the right y-axis here. So it goes up to about, 18 volts or so, or 18 amps, excuse me, um, in strength. And each time you're pulsing it down, you're also changing the state of charge of the cell. So you get the full state of charge spectrum from, it looks like about 4.2 volts to just over like 3.2 volts or so. So this looks at that whole profile. And this is just the raw data, like I said. For these graphs, what's cool on this platform is you can actually customize what you're seeing, your field of view, customize the X and Y axes, and select which data you want represented in these plots. Um, and from there, so I explained a bit about how HPPC testing works, pulses applied over time, and once you get the data, you want to analyze it. So this itself doesn't really tell you much information about that cell. And you want to look at more precise information like the voltage drop or calculate the internal resistance based on the current applied and the resulting voltage change. And then after each pulse, you want to look at the relaxation voltage to see the anode polarization and any degradation or hysteresis effects on that cell. And so that requires calculations. And mind you, this analysis may only take 1 to 3 hours because I'm actually going slower than you would probably go when you're actually doing this in real time because you just click the start button, you select your data, it populates, and then you can just flip through these dashboards and it's automatically calculated for you. So all these columns at the top, those are all the values that you'd like to get from HPPC testing. Again, this is customizable too, so you can put in if you want to calculate a specific value. And then from your data, it's automatically populated into the table. So you choose what data you want to see, and it's really easy to filter out data, see what you want to understand from your data at a glance, and compare different data sets. And then finally, you have and this is just the top result graph, and you can plot the results, which I know a lot of people look at this like I, as a scientist, quickly creating a report, I would think, oh, I just want to like take a screenshot of this, right? I do the drag because that's my motion with my mouse, screenshot, done, paste in the report. But let me tell you, you could actually make a report really quickly from this data next, and that's what I want to share next. So once you have your data set up, there's a reporting feature where you go to, in this program, the report section, and you have a standardized template. Say if you're doing a lot of HPPC testing, you could have a standard report. You just select the data you want in your report and you click the make a report button and it generates a report in PowerPoint. And you can even brand the PowerPoint file so that it's branded with your company logo or however format you want. So it's an easy way if you have a big team or even a small team and you want to create standard reports to show to management, this is a quick way to get that report. And you can not just do, it's not just limited to PowerPoints, but also CSV files for that. So this takes overall, instead of like weeks to analyze the data, which you saw those pulses, imagining bringing that into Excel and analyzing it, it only takes like 1.5 to 2 days. And that's the testing itself was the first 24 hours. So just in a couple days, you can return results on an HPPC test, which is so quick. You save so much time. And then with the testing visibility, you not just HPPC, but other tests, you get that multi-site visibility. Your team can check in on what tests are currently running, when you can maybe switch a cell, and even get automatic alerts for when your test stops. You could get a text message or an email, whatever you prefer, to let you know, hey, your data is ready to look at. And or if something goes wrong, it can tell you, hey, something went wrong, go check your test. So very straightforward. The second case study I want to share is with a product OEM. So now we're not on the R&D side anymore. This is more in the production cells. And what's going on is, imagine you're assembling some device that requires several batteries per pack. And this could be like a product in your home or something like that. And you need to make sure that those batteries are quality. And so in these facilities where they're doing these quality checks, they get, say, 30 million cells per month in, and they have to test the cells in each batch and track that. And not only that, but they're doing quality testing in multiple countries worldwide. And so you can imagine trying to keep uniform standards of these tests across these sites is really challenging. And in fact, when this company like you decided, yes, we want to use Mecantis for this, the managers didn't realize the depth of the inaccuracy of the quality testing. They didn't realize that the teams were kind of like, oh yeah, it passes, like not being super diligent about that. And that's really dangerous. You don't want batteries that are poor performing or hazardous to cause some kind of safety event, and that can lead to a recall. So this is really important, right? To have quality cells for safety, um, to avoid recall, which we just saw, those recalls have been happening throughout the years. It's really bad for companies' bottom lines. So this is how this company is using Mecantis for the QA testing. Again, similar process to HPPC and all these. You have the cell metadata that's inputted, say, with barcodes into the system. So you're inputting the data from the cells into Mecantis. Then you can create a test plan for your quality testing, different measurements, and you could check the real-time status of the testing. And then once you are performing the test, you can view the data in different ways through what are called auto tables or dashboard views of the data. And these dashboard views are customizable so you can see the data at a glance. Notice on the right, the columns there aren't necessarily just like the numbers like related to the cell. They're also calculations. So your data dashboard tables, imagine you're, testing millions of cells. You can at a glance look at this, filter through the data, look, and it'll highlight in like red and stuff which ones are failing. These images do not do the platform justice. When you see the customer's dashboard view, you really get a sense of the magnitude and how easy it is to look at the data in real time. So I can't share that data, unfortunately, because it's proprietary, but because it's customizable, those managers now can see data across operations when they wake up in the morning, and they're not having to call their team and ask what's the status, how are things going? So they get that to them no matter where they are in the world. And then once you have your real-time data dashboard on results and KPIs, you can also graph the data that you're receiving. And this is in the analysis tab here. So this is kind of like a report that you're viewing. You select the data you want to see and the types of graphs you want to view to compare cells at a glance. But it's not the direct transfer report out of the program, though it's very easy. You can see here, you can generate a report from this too. So a little different from the other reports, but still a report that you can generate and view at a glance. And here's a bit of the steps for report generation. So like I mentioned here on the left side, you see the DCIR table, for instance, DC, that's the internal resistance of the cells, a half cell summary, box and whisker graph, which is viewed here on the right. So whatever data custom views you want to see of your quality data, you can view it here and then click that generate report, and then it'll generate that PowerPoint in a matter of seconds to just a few minutes if it's very long. Very quickly. And then that's used to communicate to your management on what the status is or communicate to customers, whatever you want that to be. So again, this platform has so much improved the operations of their quality assessment process for this product OEM. They now know that their testing is standardized across operations, whereas before they didn't have that to the extent that they needed it to be. They get automated notifications, so if there's any issues, they know immediately, so it saves them a ton of time. They get that near real-time visibility globally, which is incredible for their management to understand the status and address issues. And this is overall, like, those products don't you feel like you would trust them more if they had this level of data analytics and making sure they're standardized and safe, right? It reduces that risk of recall and harm, and overall faster reporting and improved accuracy and reduced labor costs, which labor costs are often the highest contributor of costs. So they're saving a ton of money and time. They love it. It's been great. So I just want to touch on before we wrap up for the Q&A, where the future of battery data analytics goes. I think we've heard a lot in recent times about AI and machine learning. A lot of companies want to move in that direction to use these advanced analytical tools. But the challenge is when you're using a tool like that, you need large, clean data sets in order to train your models. And so starting with a platform like Mercantis can help you start training that model. And because you're summing up all the data, it has data cleaning capabilities, which a lot of platforms actually don't offer. And so you can clean your data, make sure it's good, and then you can use that to train your AI models, for instance. Quantum computing is a bit further off, but that kind of modeling of cell systems is a really interesting data case, and different high-tech companies are looking into that with the quantum computing teams. They're thinking not meant necessarily in the next like year or so, but maybe the next 5 to 10 years, they'll be focusing more on that. And then finally, I mentioned a little bit about traceability, and this is a really hot topic. The US is currently deciding what it's going to do around critical mineral traceability as far as policy goes. So that's kind of up in the air. And the EU battery directive has some regulations there. But you can imagine this causes challenges for companies around understanding what's the latest regulation they need to abide by. And by to abide by these regulations and comply and not be fined, you have to be collecting this data across your value chain. And so a platform like Mercantis can take that data through the component manufacturing, even as far as the raw material side, through to vehicle assembly and everything, and connect with your larger ERP system or the company systems to make sure that the data is visible and integrated for that visibility for compliance reporting, which is becoming more and more important and already is. So overall, I hope you walk away knowing, this is the state of art when it comes to battery data analytics and management, is these custom platforms like Mercantis that provide real-time updates, that provide data cleaning tools, features for advanced analytics, and API integration into a whole company system. It's already being used from startups and cell manufacturers through the OEMs, the product companies with millions of cells. And it has that built-in flexibility to help companies no matter what stage they are of scaling. And so we've seen customers have real impacts around reducing time and cost and making sure that they're getting the most of their data. They're understanding the value of their data. And that's something that I think about a lot when I was a battery scientist in the lab. I was getting so much data and trying to communicate to my team, why is this meaningful? Why is this impactful? A lot of times, like when I was performing, this might be really obscure to mention, but like Ritfield refinement for XRD, I was having to really paint a picture to my team of why we needed to do this to understand our cathode degradation. Only the real battery geeks materials geeks will understand that reference. But anyway, this is to say that if you don't understand that technique and somebody is reporting that on your team, it's hard to understand what's the value of doing that technique. And I wish I had something like Mercantis to paint a picture for my team on what was the value I was adding to advocate for more resources for my research and for myself. And when it comes to lab managers, they need to tell their leadership, how are they improving lab efficiency? And a tool like Mercantis with that real-time monitoring of a battery lab can give them those numbers on the lab efficiency and how many testers are being used, what's the downtime of equipment and testers, what's the utilization of the lab and how efficient is it? Those are amazing numbers to back up where your operations are at and the value that you and your team are providing to the company when it comes to making sure that you're making the most of your battery data and you're using company resources in an efficient way. Because right now, I don't know about y'all, but the market is very volatile and companies are needing to get lean and focus resources on where it makes the most impact. And so being able to communicate that story to your leadership, to stakeholders, is just more and more important right now. So thank you so much for sticking around for this presentation, and I would love to answer any questions you have. Um, this is pre-recorded, so I'm not here live, unfortunately. I'm at the NatBat annual conference in Florida right now, but feel free, you can email me at info@mecantis.io. That will reach me, and I will open it up for questions now.
Thank you so much, Jill, for that wonderful talk. We really do appreciate you sharing your expertise with us today. As with all the other talks in the event, we're likely going to have lots of questions from the audience, and I can see that we do have some already, so I'll move straight onto the Q&A section now. So Jill, your first question is, what are some of the biggest challenges that you see that battery companies are facing when it comes to using their battery data?
Yeah, this is a good question. And this is something I've touched on throughout the presentation, but just to hone in on the core message is companies aren't making the most of their data right now. They are getting volumes of data, and there's simply not enough time to analyze it and to manage it and everything in with using the tools that they're currently using. And so that challenge itself, I think, is the first challenge to tackle. The first thing is, can we take what we already have, clean it, make sure it's accurate, and use that to make decisions moving forward? And so that's something that when you put your data into Mecantis, it becomes that much quicker and easier, as I was showing, to look at, to view in customizable dashboards, and to create reports. And through the combination of tools, they're all set up so that you have access to your data when you need it and can make those informed decisions and communicate what you need to who you need to communicate it to. So that I would say is uh, probably the biggest problem that companies have, is just they're not making the most of their data and they're losing a ton of value because of it.
That's a wonderful answer. Thank you so much, Jill. Now, this next question that we have follows on very nicely from that first one, which is, what are some of the blind spots in the battery industry when it comes to data management and analysis?
Yeah, when it comes to blind spots, batteries are so interdisciplinary and require teams of, not just your chemical engineers, material scientists, physicists, electrical engineers, you name it, chemists. So when it comes to the blind spots, I would say I've had experiences talking to a polymer scientist doing pack testing and validation, and I was asking them, what tests are you doing to validate this polymer for the thermal adhesive between a battery cell and the cold plate, to make sure that you have the insulation between the cell and the cold plate, but you're able to still like have that close thermal contact, so that it doesn't heat up too much and cause thermal runaway. And he was naming all these materials testing. And I asked, do you do any voltage dielectric withstand voltage testing? And he paused for a moment and thought, oh, I hadn't thought of that before, because that's an electrical engineering type of test, right? And that's just like one example. So bringing together the minds of all the people on the team in a way to look at the data is incredibly important. And making sure that different people who need certain information get that information to make decisions. And with this platform, because the different users on the team have access to it, they can view each other's data. And Michaela, who is the product manager with Mecantis, we talk a lot about analyzing battery data. What are the best practices? Where are people's blind spots? And she even says a lot of times that this comes up where companies just don't even have time to look at their data, aren't making the most of their data. Um, Sorry, I lost my train of thought just for a minute, but it's like the companies who are doing the best when it comes to their data are getting more eyes on their data. And if you just have one scientist looking at a data set, they may miss something that someone with a different skill set could understand.
Excellent. Thank you, Jill. Now we have time for one final question before we close out this session. And just a quick reminder to our audience that any questions that we don't have time to get to will be addressed offline as soon as possible. So, Jill, your final question is, would the Mercantis software platform support pack testing and analysis in addition to cell testing?
Yes, so I talked a lot about cell analysis, and Mercantis can also do pack testing. So we actually have a customer who is building packs, and they use Mercantis to store all that battery data and analyze it. And there's even features for specifically battery packs within the platform that I didn't have time to get to today. So when it comes to battery pack testing, you're getting the voltage, the current, temperature readings. There's a ton of data around not just like assembly of packs and testing on a production scale, but when it comes to pack validation and testing and traceability and understanding your risk burn down when those tests, like what's the current state of each test so that you can report that to leadership is really important. And a lot of companies struggle with getting that view on, okay, which tests have we done? What have we not completed yet? And so Mercantis is that hub of not just the pack data, the testing data and the traceability of cells through the pack assembly, but also on the side of the validation testing and the just understanding how to match cells to put in the pack. It can do a variety of custom work around battery packs.
Excellent. Thank you so much, Jill. But unfortunately, that is all that we have time for today. Any questions that we didn't have time to get to will be sent to the speaker after the event. And as with all the other talks in the event, this talk will now be available to view whenever you want for the next 30 days. So that just leaves me to say a massive thank you once again to Jill and for addressing all of those fantastic questions. And to everyone in the audience, we'll be back soon with the next talk.